You need to rent a moving truck for 2 days. Rider moving trucks charges $50 per day and 50 cents per mile. You move trucks charges $45 per day and 75 cents per mile. So let me draw this out first. So question 6. So I have one company that does $50 per day plus 50 cents per mile. I have one that does $45 per day plus 45 cents per mile. It says write an equation describing each situation. So let's look at the first situation here. So I'm going to write this as, here is A. Here's B. So let's look at A here. At A here, I don't want to adjust my brush size here. A is $50 a day. So we can write this in terms of a standard form of a linear equation, right? So we have A here is going to equal y equals mx plus b, which is our standard form of a linear equation. And what we have here is y is going to equal the slope, right, which is m. In this case, the slope here is going to be my rate of change, which is going to be 50 cents per mile. So in this case here, my slope is going to be 50 cents, or 0.50 x plus, we have b here, and b is going to represent our initial cost, right? And the initial cost per day is $50 per day. So if you were to not even drive a mile, and if you rent a truck, it's still going to cost $50 a day. So I'm going to add $50 here. And let's look at B. So this is the equation for the first one. Let's do B in a different color. So let's do this one in a different color. So I'm going to have y equals mx plus b. Y here is going to equal, for the second situation for B, it's $45 per day plus 45 cents, or 0.45 per mile, right? So which means the exact same thing. The slope is going to be our rate of change, which is 0.45 x plus our initial cost for B here is going to be, instead of $50 per day, it's going to be $45 a day. So that's the, so we now have an equation describing each situation. We have to graph them on the same x and y axis. So let's graph this. And it might be a little bit messy because I'm kind of sketching these graphs here. But so I'm going to say that this here is my x and this here is my y. So I'm going to have I'm going to have A here, which is it's going to start at $50. The y-intercept is going to be 50. So this is 50. This is going to be 45, something like that. And then what we can do is we can either do a rise over run to figure out what the next point is, or what we can do is we can just sub in an arbitrary x number to figure out what the next value is. So in this case here, I'm just going to sub in, let's say we drive 50 miles for each of them. So I'm just going to sub in another point here. So let's say if x here equals 50, what is y? Y here is going to equal to 0.50 times 50 plus 50, right? 0.50, or half of 50 here is 25 plus 50, which is going to equal 75. So in this case here, I'm going to say that this here is a 50. So in the first guy here, it's going to be 75, right? So it's going to be 75. And then for the second one, I'm going to have, again, y equals 0.50 times, y equals 45 times 50 plus 45. Oh, sorry, this is 0.75, not 45. Let me change that here. It says 75 cents here, right? My mistake. So 75 cents times 50 plus 45. So 0.75 times 50 is going to give me 37.5 plus 45. This is going to give me a value of 82.5. So I'm going to have to actually redraw my axis here because this looks really messy here. So let me do that. So this is going to be at 50 miles. So initial here is, I think it was 45. This here is 50. And then for the 50 guy here, I'm going to have 75. So this one would be like 75 here. And the next one is 82.5. 75. Let me do the first equation in pink. So this would be 50 and 75. And then the second one in green, 45 and 82.5, which is going to be here. So I'm going to have one guy that kind of looks like this, and the other guy kind of looking like this, something like that. It might be a little bit better if I use a proper scale, because this here is not a great scale. So let me actually just let me draw this out on Desmos, because again, this sketching here is pretty, it doesn't look very nice because I don't have a scale. So it might throw you off in terms of like what we're doing here. But as long as we have 2 points, what we can do, the concept is we can actually plot this graph, right? So we have 45, we have y equals 45 and y equals 82.5 at 50, and then y equals 50 and y equals 75 here. So we have 2 lines here, which means we can draw. So we have 4 points, so we can draw 2 lines here, and that's kind of the concept for this. But let me use Desmos to show you what this graph actually looks like. So I have y equals, or I have 0.50x plus 50, and the second one here is I have 0.75x plus 45. So it looks something like that. So kind of like what I did before, but with a better scale here. So I kind of drew my graph like that. But this here is a better graph than my graph, obviously, because I'm sketching it. But that's kind of what we want to visualize here. And saying, so we have graph, so we're good. It's asking from your graph after how many miles would the trucks cost the same? So that's A. So if we want to find that out, what we can do is we can simply, we have 2 equations here, and we can actually use substitution, right? We can substitute one equation into the second one and then solve for our x value. So that's how you would do it algebraically if I were to solve for this instead of graphically. So I'm going to have 0.50 plus 50 equals 0.75x plus 45. I can move all the x's to one side, so I'm going to subtract 0.75x from both sides to get negative 0.25x on this side. Plus 50 is going to equal 45. 0.25x equals 45 minus 50 here. I'm going to minus 50 from both sides, which is going to give me negative 5. X is going to equal negative 5 divided by negative 0.25, which I believe is 20. Yes, 20. So basically, if I were to equate these two, the point of intersection for both these lines are going to be at 20 degrees, or at 20. So this point should be at 20. So in 20 miles, the trucks would actually cost the same. So it's asking here is, which company will give you a better deal if you drive less than 30 miles? Well, if you drive less than 30 miles here, the better deal would be the B line, right? The second company here, because if I drove less than 30 miles here, the initial cost is going to be, it's going to be equation A here, not equation B. Equation A here, because the slope here is less steep than 0.75 here, right? So although you're paying more for the initial cost here, which is $55 more, you're driving less miles. So the slope here, the 0.5, the rate of change here is going to be less. However, if you're driving more, C here, which company will give you a better deal if you drive more than 60 miles? Well, for more than 60 miles here, I think this is 0.75. Oh, this is 0.75 plus 75. Sorry. So sorry, it's asking which company will give you a better deal. It's actually B. Because again, although the rate of change here is steeper, but you're paying less for the initial cost. And then for C here, it's going to actually be the first company, because although you're paying more for the initial cost, you're actually paying less because you have a rate of change that is less than 0.75. So for B, the second company is cheaper, and the C, the first company is cheaper here. And we can actually plug this in. We can plug in 30 for X here to solve, to figure out which one would cost more. But we could also look at the graph here. So let's look at the graph here for B and C. So which company will give you a better deal if you drive less than 30 miles? So let's look at our X values here. And let's say we're driving less than 30. So this here is the 30 line for both here. So I want, obviously, if I'm driving less than 30 miles, the cost here of the blue line is much greater, right? So I would follow the cost of the red line, which is going to be the first company, like I said before. Even though the initial cost is higher, I'm driving less miles, so it doesn't matter as much. But then if I were to be driving 60 miles here, I can zoom out here and look at 60. So this here is 60. As you can see here, the blue line is now much steeper than the red line here. So the cost here, the cost of this line here is going to be, less for the orange line here. So the first company here is going to be cheaper. So 30, but if I were to be driving less than 30 miles here, the blue line is cheaper, right? If I'm driving 20 or less, the blue line is definitely cheaper here as well. So this solution, I think this is supposed to ask us 20, because that's the point of intersection, but that's okay. This here is a solution. Again, they wrote the solution correctly as well. I believe it's 90. Oh, this is 90 and 100. So I don't think they actually graphed this correctly. It's $50 per day and $45 per day here. So this graph is actually wrong. This is supposed to start from 50, and this is supposed to start from 45. So they actually graphed this wrong here. So, so let's see. Let's look at their answer here. At 40 miles, both trucks are $120, and as I told you that it was at 20 miles, so they actually wrote the wrong values here. For less than 30 miles, umove is better. For 60, Ryder is better. So umove was the second company, and the Ryder was the first company. So the solution is actually incorrect because they failed to plot the graph correctly, and it's at 20 miles. The cost of both trucks are the same, right? So I'm going to write solution here is incorrect. The graph is incorrect because the y-intercepts are supposed to be at 5 and at 50. At 20 miles, the costs of both truck companies would be the same. So the solution here is incorrect.